start this. So today, today we are going to have a talk regarding one of the most important terms of the physics, which we call it as electric field intensity. Heard or not? Okay. So yeah. So this topic means this whole topic has a very good understanding. Heard or not? So till now you might have seen like 1 minute. Let me check on YouTube whether it is working fine or not. Yeah, it's working fine. Okay. So till now we did Coulomb's law and we did many questions regarding that stability and all these are there. There are some more questions, some two to three different types. I'll discuss it after discussing the electric field intensity. Got it or not? Like we will discuss the joint effect of Coulomb's law and electric field intensity on those three different cases, and then we'll move ahead. Is that clear? Yeah, so let us first develop the concept of this electric field intensity and then we'll move ahead. Is that clear? Yeah. So, first important point, why this field intensity and why it was brought? That's a big question. Got it or not? So, give the heading electric. First, we will define electric field. Means what is our electric field? Got it or not? Okay. Now, wow, let's take an example. Have you seen the cave of a land? Yeah, we have. Yeah, hi Riva, be there. Okay, so we have the cave of a land, isn't it? Acha. In that cave, what happens? See, the land will not attack. Let's suppose if you are 1 kilometer away from the particular cave, is the land is going to attack you? No. But as you start coming nearer and nearer, you can feel that ऐसा अरे भाई दिल का धड़कन तो एकदम तेज होने लगा है ना? ऐसा दिल का धड़कन एकदम बढ़ जाएगा and you will feel like oh the lion is going to attack, the lion is going to attack and so on. That kind of feeling will start appearing over there. That particular fear is called as field intensity. Is called as field intensity. That fear which this particular person is feeling, that yes, this lion is going to attack as I move nearer to it. That particular presence of that effect of force which the person is feeling is called as field intensity or field. Are you able to get me or not? And this is how we are going to develop our whole physics and whole effect thing. Okay, so what is electric field? This is not a practical. This is not a practical case. So we will look on the physical description of it. So how we define it? It is the region around any charge in which the effect of charge can be experienced. सिंपल भाषा में मैं लिखवा रहा हूं क्या है कि the region around any charge, it is particular kind of a region which will be present around any of the charge in which you can feel the effect of the charge over there. Are you able to get me or not? Means you will feel something. Yeah, you will feel the presence of it. Is that clear or not? Is that perfectly clear? Yeah. So let us move ahead with this, and uh, this effect, this presence is called as electric field. In simple language, I'll write it. Okay, this presence is called as what? Electric field. Got it or not? So let us understand how this electric field is means. अब क्वेश्चन आता है कि सर आपने लाइन का तो एग्जांपल प्रैक्टिकली बता ही दिया है ना कि what will happen, isn't it? Are you able to get me or not? So instead of land, instead of this land and all, this time, this right now over here, we will see how the electric field strength is felt by the charges now, right or not? So to understand that, we have two ways. There are two ways to understand. There are two ways to understand electric field. Basically, those two ways are Okay, the first one is we call it as electric field strength. We measure the electric field by electric field strength or intensity. Yeah, it's called as electric field strength or intensity. Or second thing to measure the electric field is my electric potential, by the term called as electric potential. Are you able to get me or not? So there are two ways to understand whether there is electric field or not. The first one is by measuring using the electric field strength or intensity, and second one is through the electrostatic potential. Is that clear or not? Is that clear? मजा आ रहा है, फील आ रहा है? तो अपन ने प्रैक्टिकल क्या समझा कि सर कुछ नहीं, अगर एक चार्ज है, चार्ज के अगल बगल एक रीजन होता है, इस रीजन में दूसरा चार्ज आके अपने ऊपर सोचता है कि मीन्स दिस चार्ज इज फीलिंग समथिंग, और इसलिए ये जो फील्ड ऑफ स्पेस है उसका नाम दिया गया इलेक्ट्रिक फील्ड, इलेक्ट्रिक फील्ड, वर्ड और नॉट? नाउ you can see that that when this charge is experiencing that field, let's suppose this is my charge which is at rest over here, okay, and I made another charge capital Q to move towards this side, right or not? What will happen? This charge will feel, oh, I'm feeling something over here. Then he will come nearer. Yeah, means this charge which has started to travel towards right, it will feel that कि अरे भाई यहाँ पे कुछ तो हो रहा है, फिर यहाँ पर फील होगा कि अरे यहाँ पे कुछ और ज्यादा फील हो रहा है, फिर यहाँ पर फील होगा कि अरे यहाँ, yeah. So what do we can observe means this electric field intensity is not uniform. It varies with respect to different point in the space or not. So the first point will say, but we will say we'll use the term as point, that with respect to point in the space, this electric field intensity start to varies, and the charge experiences different kinds of force at different points over here. Are you able to get me or not? And this variation which we are going to understand is brought by some relation, and that's what we are going to understand now. So give the heading electric field intensity. So right now we understood electric field, then we'll try to understand electric field intensity. Is that clear or not? Got it? Okay. So let us understand what is electric field intensity. Nothing but any point where electrostatic force is experienced by test charge, any point where electrostatic force is experienced by test charge, any charge which you can consider, right or not? With this charge means, अरे बाबा जैसे अब शेर के सामने एक पर्सन को खड़ा कर दिया, तो वो पर्सन क्या है, टेस्ट ऑब्जेक्ट हो गया ना, तो बस वैसे ही, तो इलेक्ट्रिक फोर्स व्हेन, yeah, so whenever the electrostatic force is experienced by any test charge, then the force experienced per unit charge is called as electric field. Electrostatic field intensity. Is that clear? So सिंपल सी भाषा में छोटे वर्ड्स में बोलेंगे कि मान लो कोई भी चार्ज है, तो चार्ज जो भी टेस्ट चार्ज, जैसे इस चार्ज के सामने अगर ये मान लेते हैं कैपिटल क्यू रेस्ट चार्ज है, ठीक, then if I bring a test charge, let's suppose I bring a test charge, a small q towards it, so the force experienced by this charge will be defined as electric field of this particular capital Q. Are you able to get me or not? So simple. That means force will be equal to, electric field will be equal to force experienced by the charge which is moving. Are you able to get me or not? But remember that this electric field is not for charge moving. This is for the capital Q which is at rest. Are you able to get me or not? Okay. So, uh-huh. Yeah, that test charge which is moving. So the point is very, very simple that we have to take care of one thing. That electric field is defined for a rest charge, right or not? And the force is experienced by my moving charge which is brought over here. So you have to always keep in your mind, always this needs to be in your mind, that your rest charge applies the electric field, applies the electric field, while moving charge experiences the force. Now the question starts that, sir, if you are talking this much about rest charge and moving charge, then if there is some kind of force which is applied on this Q, then the what is means the question arises that what will be the direction of this electric field of these charges, isn't it? So to talk about direction, the direction of electric field is similar. I'll have to consider this as negative charge because this is attracted towards over here. Right or not? Okay. So the direction of electric field is similar to the direction of force experienced by charge, yeah, by test charge at any point. Is this clear or not? Are you able to get me totally? Okay. So this is your whole concept of electric field, and that's how we are going to define. So let us see how we are going to define. So uh, 1 minute, 1 minute, 1 minute. Yeah. So let us see how this happens. Let's suppose if I have any positive charge, set. Okay, and in front of it another charge is moving. Right or not? So let's suppose these are my two different charges. One is plus capital Q, okay, which is raised, and then we have plus test charge, which is plus Q naught. It is denoted as plus Q naught. Are you able to get me or not? So this is my test charge. Okay. Now remember एक बात बता दे रहा हूँ. Conventionally ये याद रखना, a test charge is always taken positive in nature. Are you able to get me or not? हरदम हम टेस्ट चार्ज को क्या मानते हैं बेटा? पॉजिटिव और and very small. Yeah. Now, what will happen? These two charges will repel each other. If they have some distance d apart, this charge will feel some force away from the capital Q or not. It will try that, अरे यार मैं तो दूर फेंका जा रहा है कि नहीं? Now, if the distance is r over here between the charges, then that force we know that is given as k. Yeah, if this space is vacuum, then 4 pi epsilon naught plus q into a small q divided by r square, isn't it? But right now, we defined our electric field. That electric field is forced by charge, isn't it? The charge which is moving. So electric field of raised charge Q at this point P will be what? Forced by the charge which is moving, which is Q naught. And if you replace this, what you are going to get? 1 by 4 pi epsilon naught capital Q by R square. And this is the formula of electric field intensity due to any raised charge at any point P. Are you able to get me or not? Q by R square. Now, since the charges were positive, right now I told you the direction of electric field is similar to the direction of force experienced by the test charge. So the force is experienced by plus Q is towards this side. That means the electric field intensity due to the plus Q at this point must be along the direction of force which is away from the charge itself. Are you able to get me or not? So this is how simple that we know that the electric field will be in the direction of force, isn't it? Now plus Q is experiencing the force away from the plus Q charge, isn't it? So the electric field will be in the same direction of force. That means for any positive charge, the electric field is always away from the charge itself. Are you able to get me? Yeah. Now if the test charge would have been negative, तो force किधर होता? इस डायरेक्शन में होता. तो electric field की डायरेक्शन कैसे होती है बेटा? Yeah. Yeah. Okay. So based on this point, we will define the property of plus charge and minus charge. If it is plus Q and if it is minus Q. Okay, right. Let me write plus capital Q minus Q capital. So if these are two different charges, okay, then for plus Q, the electric field always points away from the charge. And for minus Q, the electric field is always towards the charge for negative charges. Is that clear or not? Is this perfectly clear? And this is why we define there are different kinds of systems. So we define first thing that for positive charges, electric field points away from charge, and for negative charge, the electric field points towards the charge. Is this clear or not? Is this perfectly clear? Yeah. Now, so we got to know about electric field intensity, electric field. But the question arises that, sir, we know that the charge can be of any shape. Like the charge can be a point also, charge can be spread on a sphere also, charge can be present on a line also, a rod also, charge can be even present on a ring also, isn't it? So there are many geometrical shapes which we need, which are present in our universe, and we will talk one by one about them. But the first thing is, we'll first talk about this electric field due to a point charge. Are you able to get me or not? And then we'll move ahead with the electric field of different kinds of systems which we have to discuss. Is that clear? So let us understand the first thing, electric field intensity due to point charge. Okay. Now, let's suppose if I have any point charge. Point charge means its dimension is negligible, right or not? So if there is a point charge which is placed in any space which is given over here, then what will happen is this point charge will apply. Let's suppose I okay. Let us change our representation. We are representing the rest charge as capital Q, isn't it? So this capital Q will apply some kind of field at any random point which is kept in space, which is located at some distance r. मतलब कोई भी चार्ज भैया अगर स्पेस में पड़ा हुआ है तो वो उस पॉइंट के ऊपर कुछ ना कुछ फील्ड तो अपनी अप्लाई करता है. हमने अभी निकाला कि दैट फील्ड इंटेंसिटी इज एग्जैक्टली गिवन एज 1/4πε0 q by r square. So किसी भी पॉइंट चार्ज के वजह से the electric field at any point is given as 1/4πε0 q by r square. Now, this electric field, since this is pointing in one direction, is always a vector quantity. किस तरह की quantity है ये? Now, if it is a vector quantity, then we know that it will also follow superposition principle. It will also follow सुपरपोजिशन प्रिंसिपल. तो अपने को इस इलेक्ट्रिक फील्ड में तीन चार चीजें मालूम चली. फर्स्ट पॉइंट ये मालूम चला कि सर इलेक्ट्रिक फील्ड इंटेंसिटी क्या होती है. इट इज नथिंग बट द फोर्स एक्सपीरियंसेस बाय अनदर चार्ज. इसका मतलब एक जो रेस चार्ज खुद बैठा हुआ है उसका कुछ ना कुछ अपना एक टेंडेंसी है, एक अपना एक फील्ड है, और उसी फील्ड के बारे में हम बात कर रहे हैं. तो किसी भी पॉइंट चार्ज की वजह से, कोई भी पॉइंट चार्ज मान लो, उसके वजह से किसी पॉइंट के ऊपर जो फील्ड इंटेंसिटी होती है, that is exactly equal to 1/4πε0 q by r square. And this field intensity is always a vector quantity. कौन सी quantity है बेटा ये? So therefore E vector is represented as 1/4πε0 q by r square r cap, where r cap represents the direction of electric field. Is that clear? Okay. Now, so this was regarding one charge. Now we know that there can be many charges at one point, isn't it? तो अगर मान लो बहुत सारे चार्जेस प्रेजेंट है, लेट्स सपोज देयर आर इनफाइनाइट नंबर ऑफ चार्जेस प्रेजेंट एट एनी पॉइंट. So I'll just okay, I'll just bring some four charges. They are spreaded in this universe like this way. Okay. Why don't know? And each charge, let's suppose this is plus q, this is plus q1, this is plus q2, this is plus q3, this is plus q4. Got it or not? Now, in this space, there are how many charges? Infinite number of charges. Now, I told you that at any random point P in the space, find the field intensity. मतलब इसका कहने का मतलब ये हुआ कि मान लो सर एक केव है, केव के अंदर चार पांच शेर है ना, और उसके सामने तुमने एक पर्सन को खड़ा कर दिया, तो भाई इस पर्सन के ऊपर चारों शेर मिलकर अटैक करेंगे ना. ऐसा थोड़ी ना होगा कि एक शेर अटैक करेगा, एक शेर अटैक नहीं करेगा. चारों शेर मिलके क्या करेंगे? अटैक. तो जो फील्ड इफेक्ट, जो फोर्स फील होगा उस पर्टिकुलर पर्सन का, वो मैक्सिमम होगा या नहीं होगा? Yeah, so here this is what is going to happen. Let's suppose if I have these charges, then the field experience is the field experience by this any raised charge which is kept at point P will have must a vector sum of all these field or not. पहले अच्छे से समझते हैं कि सर एक बात बताओ, इस डिस्टेंस r पे जैसे मान लो ये r1 हो गया, ये r2 हो गया, ये r3 हो गया, ये r4 हो गया, तो q1 की वजह से एक इलेक्ट्रिक फील्ड होगा, q2 की वजह से एक इलेक्ट्रिक फील्ड होगा, q3 की वजह से एक इलेक्ट्रिक फील्ड होगा, q4 की वजह से एक इलेक्ट्रिक फील्ड होगा या नहीं होगा? और इलेक्ट्रिक फील्ड कौन सी क्वांटिटी है, वेक्टर या स्केलर? तो अगर इलेक्ट्रिक फील्ड वेक्टर क्वांटिटी है, इफ माय इलेक्ट्रिक फील्ड इज अ वेक्टर क्वांटिटी, देन इट विल नॉट गो थ्रू अ नॉर्मल सम, it will go through a vector sum. So E net will be E1 vector plus E2 vector plus E3 vector and so on. Is that clear or not? And therefore E net at point P due to these many charges is given as E1 क्या हो जाएगा? I'll take 1 by 4 pi epsilon naught common. It will be Q1 by R1 square R1 cap plus Q2 by R2 square R2 cap and so on. Is that clear or not? And this is a vector sum, guys, because R1 is here, R2 is in this direction. So these two vectors are in two different directions. That's why it is necessary to mention R1 cap and R2 cap over here. Is that clear or not? मेरी बातें समझ में आ रही हैं? Clear? चलो, so have a quick revision of this, then I'll ask some questions, then we'll move on. ठीक है? देख लो एक बार. ओके, बोल रहे हैं मान लो एक पॉजिटिव चार्ज Q है ना, एंड आई सराउंड दिस विद अ सर्कल. बोल रहा है we know that the electric field lines of plus Q will emerge away from it, isn't it? है कि नहीं? क्वेश्चन पूछ रहा है तुमसे कि एक बात बताओ सर, अगर मैंने ये दो पॉइंट्स कंसिडर किया, लेट्स सपोज आई कंसिडर दिस टू पॉइंट्स, पॉइंट ए एंड देन पॉइंट बी, देन ऑप्शंस आर फर्स्ट और ऑप्शन ए इज electric field at A will be more than electric field at B. Option B, electric field at A will be less than electric field at B. No, there are different points, random points in the space. Electric field due to A is exactly equal to electric field due to B. Option D, none of this. Tell me which one of this is correct. बताओ जल्दी से. इतना टाइम क्यों लग रहा है बेटा, एक बात बताओ. It should be C because सही बात है. Is sir the point in a space are exactly located at same distance away. तो ये ऑप्शन मींस जो भी फील्ड इंटेंसिटी यहाँ का होगा वो ही सेम फील्ड इंटेंसिटी यहाँ का होगा. लेकिन इज मींस यहाँ पे बोलना है कि इनका मैग्नीट्यूड सिर्फ सेम है ना, इनकी डायरेक्शन सेम नहीं है. एट दीज टू डिफरेंट पॉइंट्स द डायरेक्शन इज टोटली डिफरेंट. आर एबल टू गेट मी और नॉट? सो नाउ मूव, लेट अस मूव टू नेक्स्ट क्वेश्चन. बोल रहा है एक क्वेश्चन समझना. क्वेश्चन पूछ रहा है कि बोल रहा है कि इफ देयर इज अ चार्ज ऑफ -10 microcoulombs, the charge is given as Q is equal to -10 microcoulomb and इसकी जो मास है दिया हुआ है it is exactly equal to 10 micrograms. Then question is find the electric field intensity to balance the weight of charge in vacuum. बताओ. बोल रहा है कि फाइंड द इलेक्ट्रिक फील्ड इंटेंसिटी टू बैलेंस द वेट ऑफ चार्ज इन वैक्यूम। क्या हुआ? जल्दी से बताओ। देखो, अच्छा ये चार्ज कौन सा है? नेगेटिव चार्ज है ना। 10 - 10 माइक्रो कूलम लिखने का मतलब ये क्या है? 10 to the power of -6 कूलम, isn't it? ये नेगेटिव चार्ज है बेटा। अब बोल रहा है कि दिस नेगेटिव चार्ज इज हैंगिंग इन स्पेस। ठीक। हाउ इट इज हैंगिंग, हाउ इट विल हैंग? ये एक नेगेटिव चार्ज है। लेट मी इरेज दिस। सॉरी, this is my negative charge which is given to you, and it is hanging in a space such that its weight is balanced, है कि नहीं? अब एक बात बताओ, ये weight कैसे बैलेंस होगा? There should be some force, yeah, there should be some force in the opposite direction that will balance the weight or not, isn't it? Yes. Now the question arises that what is this force? Now see, in the question it is saying that find the electric field intensity that will balance the weight of the body. Now that force, this means that this force is generated. जैसे मान लो अगर तुमको किसी भी चीज को खड़ा करना है, मतलब जैसे मान लो किसी ऑब्जेक्ट को ऐसे पकड़ के रखना है स्पेस में, तो तुम हाथों से पकड़ के रखते हो, मतलब तुम फोर्स अप्लाई कर रहे हो। अपन को यहाँ पे वेट बैलेंस करना है तो अपन फोर्स अप्लाई करेंगे, बट फोर्स किसके थ्रू अप्लाई करेंगे? थ्रू द इलेक्ट्रिक फील्ड इंटेंसिटी। तो क्वेश्चन आता है कि इलेक्ट्रिक फील्ड इंटेंसिटी कितना होगा? तो हमें मालूम है कि the force experienced by any charge in the presence of electric field is equal to how much? QE. F will be equal to how much? Q into E होगा ना भाई, बोल यार हाँ या ना, यही होगा ना? So that means I can write it over here that this force will be equal to how much? Q into E, and that must be equal to how much? mg, such as to balance my weight of the body. Are you able to get me or not? So force experienced must be equal to Q into electric field, and that must be equal to mg. तो इलेक्ट्रिक फील्ड की वैल्यू कितनी आएगी? मास दिया हुआ है 10 माइक्रोग्राम, सो 10 into 10 to the power of -6, g हो गया तुम्हारा 10, डिवाइडेड बाय चार्ज तुम्हें मालूम ही है, दैट इज 10 into 10 to the power of -6, so that means the electric field must be equal to 10। और इलेक्ट्रिक फील्ड का ऐसा यूनिट क्या हो जाएगा बालक? तो ध्यान से देखो, तो एज इलेक्ट्रिक फील्ड इज इक्वल टू फोर्स बाय चार्ज, फोर्स का होता है ऐसा यूनिट न्यूटन, क्यू का होता है कूलम्स, तो इलेक्ट्रिक फील्ड इज ऑलवेज मेजर्ड इन न्यूटन पर कूलम। सो दिस मस्ट बी इक्वल टू 10 न्यूटन पर कूलम्स। आर यू एबल टू गेट मी और नॉट? But my question is very simple. In which direction this electric field should be present? In which direction this electric field should be present? It should be towards the charge because it is. So how come negative charge will give me the idea that it should be present towards the charge? Because very simple sir, अगर हम ध्यान से देखें तो मान लो अगर किसी स्पेस में प्लस चार्ज है, अगर मान लो किसी सिंपल सी बात है सर कि मान लो अगर इलेक्ट्रिक फील्ड इस डायरेक्शन में प्रेजेंट है ना, और अपने पास दो चार्जेस हैं, एक है पॉजिटिव और दूसरा है नेगेटिव। ध्यान से सुनिए बालक, मान लो अपने पास कितने चार्जेस हैं, दो, एक है पॉजिटिव और दूसरा कैसा है, इज दैट क्लियर और नॉट? So let's suppose if electric field is present in this direction and this is my plus charge and this is my minus charge, then we know that plus Q will experience the force in the same direction, isn't it? क्योंकि जो फोर्स होता है, फोर्स इज इक्वल टू क्यू ई, और क्यू ई मतलब क्यू पॉजिटिव है, ई पॉजिटिव है, तो फोर्स कैसा रहेगा, पॉजिटिव, है कि नहीं? But F is equal to QE. If it is a negative charge, it will come as a negative value over here or not. So the force experienced by negative charge is in which direction? Opposite of the direction of given electric field. Isn't that true? This is my force direction for the negative charge. So in any electric field which is given over there in the space, remember that the force experienced by positive charge is always in the direction of electric field, while the force experienced by the negative charge is always opposite of the direction of electric field. So if it is a negative charge and I want my force to be upwards, then definitely my electric field should be downwards, such that the body should be lifted upwards in the direction. Is that clear or not? सत श्री अकाल, सलाम, जे लीडर्स के बच्चों, इज दैट क्लियर? चलो, तो दिस वाज अबाउट योर इलेक्ट्रिक फील्ड डायरेक्शन. सी, remember that electric field direction for plus charge is always away, negative charge is always towards the charge. But when it comes to the effect of electric field, so you have to always think that how the force will be applied. Is that clear or not? Okay, let us do one more question. बोल रहा है a proton is in equilibrium in uniform electric field. A proton is in equilibrium in uniform electric field. If suddenly the electric field direction is changed, if suddenly the electric field direction is changed, then find the acceleration of charge. Then find the acceleration of proton. Okay. So options are A, G, option B, 2G, option C, G by 2, option D, none of this. चलो, ऑप्शन भी दे दिया तुम्हें, तो मैंने बोल रहा है कि एक प्रोटॉन है, ठीक है, प्रोटॉन का मास मान लो, चार्ज मान लो, ठीक. सो अ प्रोटॉन इज हैंगिंग इन द स्पेस, ठीक, in uniform electric field. Then I reverse that direction of electric field. If I reverse the direction of electric field, you have to find the acceleration of the proton. The options are G, 2G, G by 2, and none of this. इसे बोलते हैं क्वेश्चन. मतलब पता नहीं कहाँ कहाँ से निब्बा निब्बा टीचर्स आ जाते हैं, इधर उधर से कुछ भी पढ़ाते रहते हैं. बताओ क्या होगा? Find the acceleration of proton when the direction of electric field is changed. Hmm. It's an easy question, I'm really saying. Okay, you have to just think about the different cases. Okay, चलो मैं बताऊं, आसान है। बोल रहा है कि सबसे पहले देखो, मैं बार बार बोलता हूँ क्वेश्चन पढ़ना सीख। पहले ही बोल रहा है कि द प्रोटॉन इज इन इक्विलिब्रियम इन एन यूनिफॉर्म इलेक्ट्रिक फील्ड, है ना। और प्रोटॉन है भाई, तो मालूम है तुम्हें कि कोई भी प्रोटॉन पॉजिटिव चार्ज का होता है ना। होता तो है ना। अरे हाँ या ना। और प्रोटॉन पॉजिटिव चार्ज है तो उसकी वैल्यू लिखते हैं हम कैसे, प्लस ही। यही लिखते हैं ना प्रोटॉन का चार्ज। ठीक, अच्छा। तो प्रोटॉन इक्विलिब्रियम में है, तो इसका मतलब क्या है कि प्रोटॉन के पहले पास को वेट होगा उसका, वेट होगा, एंड दैट वेट must be balanced by some force which will be exactly equal to E into electric field. Yes, and that will this will be the force which will be applied on the proton, which will try to balance the particular proton in the uniform electric field or not. So that means this force E into E must be exactly equal to mg, such that the proton is in equilibrium. So how much is that electric field? It will become mg by E. This is my electric field, isn't it? Now, what we do, what we are doing for this proton only, yeah, I'm reversing the direction of electric field, isn't it? So look over here. First of all, this proton has plus E charge. Second thing, it has weight mg. Now, in the direction of mg only, this electric field is once again brought over here or not? Because after reversing the electric field is present in which direction? Downward direction. Yes. Now it is downward. See, to keep the proton in equilibrium, the electric field must be in which direction? Upward direction. Because in the same direction, the force will be applied and the proton will be in equilibrium. Now, as a reverse, the electric field will be in the direction of mg only, isn't it? So therefore, now for the reverse case, the force will be how much? Mg plus E. Yes, sorry, mg plus Q into E. Because this electric field will apply a force now in the downward direction, which will be exactly equal to how much? Q. So the force become how much? Mg plus E. सो नेट फोर्स रिवर्स डायरेक्शन में कितना हो गया? mg प्लस ई इंटू इलेक्ट्रिक फील्ड का वैल्यू हमें मालूम है, mg बाई ई, ई कैंसिल। सो नेट एफ नेट कितना आया? ट्वाइस mg। और तुम्हें मालूम है एक्सेलरेशन निकालना है, तो एफ नेट इज इक्वल टू, इसकी मास मान ले m है, तो m इंटू ए इज इक्वल टू ट्वाइस mg mm. So a is equal to twice c. So how much is the acceleration of the charge when the field is reversed? Twice g. मैं एक बार फिर से एक्सप्लेन कर दे रहा हूँ सिंपल भाषा में। चार्ज पहले इक्विलिब्रियम में था इन द प्रेजेंस ऑफ इलेक्ट्रिक फील्ड, सो द फोर्स विल बी अपीयरिंग इन द पॉजिटिव डायरेक्शन ड्यू टू द इलेक्ट्रिक फील्ड इन द अपवर्ड डायरेक्शन, एंड दैट फोर्स विल बैलेंस बाय a weight of the body. So that means we got the value of electric field, which is mg by e. Now I reverse the direction of electric field and I want to find the acceleration. So as I reverse it, the force in the downward direction appears, which is exactly equal to QE. So downward total force becomes mg plus QE, and that force starts to accelerate my charge downward. So F net becomes mg plus E into mg by E. E cancel, mg plus mg, F net is equal to 2mg, और एक्सेलरेशन कितना आया? डाउनवर्ड डायरेक्शन में। और किस डायरेक्शन में ये एक्सेलरेशन बेटा? डाउनवर्ड डायरेक्शन में, विच इज एक्जैक्टली इक्वल टू 2। इज दैट क्लियर और कॉन्सेप्ट समझ में आया? ओके, चलो फिर एक और क्वेश्चन बनाओ। फिर क्वेश्चन बोल रहा है कि लेट सपोज I have a charge of 1 microcoulomb and it is placed in at origin. I have a charge of 1 microcoulomb and I place this charge at origin. Then find the electric field intensity. at point 3 by 4 meters. बताओ. Options are option A 62 3 I cap plus 4 j cap. Option B 68 4 I cap plus 3 j cap. Option C 72 3 I cap plus 4 j cap. Option D none of these. Hmm. Which option is correct? Tell me first, tell me first, tell me first. अच्छा, दिया क्या हुआ? सबसे पहली बात, लेट अस अंडरस्टैंड. मतलब हमने एक एक्स वाई प्लेन लिया, है ना, और अपने एक चार्ज को कहाँ पर बैठा दिया? ऑरिजिन पे. यस. एंड दैट चार्ज इज एग्जैक्टली इक्वल टू 1 micro coulombs, isn't it? But I want to find the electric field somewhere in the space which is located at point P, and the coordinate of point P is given, which is 3 comma 4, isn't it? The coordinate of this point is how much? 3 comma, and I want to find the electric field. First thing is that since the charge is positive, the electric field will be in the same direction, and that will be away from the charge, isn't it? This will be the direction of electric. Now, as we are getting the coordinate form, since we didn't have this r distance, we have what? Coordinate form over here or not? So remember that for that you have to apply the vector equation of electric field. And the vector equation of electric field says what is that relation? 1 by 4 pi epsilon naught q by r square r cap. Isn't it? Now, this origin has coordinate 0 comma 0. So our r vector I can get easily. It will be what? 3 minus 0 I cap plus 4 minus 0 j cap. So r vector is what? Simple, 3 I cap plus 4 j cap, and I have to find r cap. So to find r cap, I need to find the magnitude of r, which will be how much? Root under 3 square plus. So how much is that? 5 units. Actually, meter is that. So that means r vector is how much? Magnitude of r vector is how much? 5 meters. So electric field क्या आएगा? Simple, electric field will be 1 by 4 pi epsilon naught. That is 9 into 10 to the power of 9. Q is given to you 1 microcoulomb, so 1 into 10 to the power of minus 6. R square, we got our magnitude of R, which is how much? 5 square, isn't it? That will be my R square. And then R cap is nothing but R vector by magnitude of R vector, isn't it? R vector is 3I cap plus 4J cap divided by magnitude of it, which is 5. Are you able to get me or not? So when you solve this, how much you are going to get? 9 10 to the power of 9, 25, 125, 72 is a 1000. Yeah. So E vector becomes 72. Almost it will come as 72. 3I cap plus 4J cap. That's my value of the electric field in the vector fall. Is that clear or not? Are you able to get me? कॉन्सेप्ट समझ में आया? ओके, कैन आई मूव अहेड? ओके, YouTube guys, are you able to understand me perfectly? If you can understand, then reply with a yes or no. Then we'll move ahead. Okay? चलो ध्यान से देखो। तो ये तुम्हारे दो अलग अलग टाइप हो गए। एक तो हो गया बैलेंसिंग ऑफ चार्ज, रिवर्स डायरेक्शन कैसे होता है। दूसरा हो गया तुम्हारा वेक्टर फील्ड। अब इसी वेक्टर फील्ड में एक और आता है विच वी कॉल इट एज वी नो रेजोल्यूशन ऑफ चार्जेस। मीन्स व्हाट वी डू इज where is the triangle? Is there a triangle? Yes, there is a triangle. So what we do, we take some charges and then we place on the vertices of this triangle. Let's suppose on this vertices I place some charges. One is, let's suppose here it is plus q, then over here it is also plus q, and then over here it is also plus q. Question is, find the electric field on any charge at one vertex. बताओ, ये तो आसान है। इसका एक प्रोटोटाइप हमने कर लिया था, है ना? बनाओ, ट्राई करो बनाने का। तो एक बात तुम्हें मैं बता दे रहा हूँ, इस पूरे फिजिक्स में ना एक चीज बड़ी कॉमन है। कैन यू हियर मी? Yeah, so what is that thing common over here is you have to remember that whenever there is a vector now, see, whenever there is a vector quantity, when we are involving a calculation of a vector quantity, then always draw that vector quantity. Like अगर जैसे force vector है, acceleration vector है, velocity vector है, electric field vector है, तो इन सबको पहले draw किया करो कि किस direction में ये actually में present है. Are you able to get me or not? Then only you do the next calculation. Then you will approach a correct answer. Otherwise, you will never approach a correct answer. Okay. So my first task is to find the direction of electric field on a given charge. तो ध्यान से देखो भाई, ये चार्ज है तो इसके ऊपर ये प्लस क्यू और ये प्लस क्यू का इलेक्ट्रिक फील्ड होगा ना. This plus q will apply the electric field in this direction, and this plus q will apply the electric field in this direction. Let's suppose the length of the triangle is L. So the this one will apply E exactly equal to 1 by 4 pi epsilon naught Q by how much? L square. And this one will also apply E vector is equal to 1 by 4 pi epsilon naught Q by L square. So what I did nothing. I just represented my electric field. That's what I told you. That whenever you have the vector quantities, you try to always draw the diagram. Okay. अब ध्यान से देखें तो सेकंड पॉइंट हमें मालूम है कि ये जो वेक्टर क्वांटिटीज हैं, these are my two vector quantities and we can't generally add them. We can't ऐसे ही मतलब उसके ऐड नहीं कर सकते. हमें क्या करना होगा? हमें इन दोनों के बीच में रिजल्टेंट फाइंड करना होगा. So we know that this angle is 60, so this angle will be also how much? तो रिजल्टेंट निकालने का तरीका क्या है? अगर सर दो वेक्टर क्वांटिटीज दी गई है तो उनके बीच की जो रिजल्टेंट होती है दैट इज गिवन एज रूट अंडर ए स्क्वायर प्लस बी टू ए बी, हाँ, टू ए बी cos theta, isn't it? Where theta is the angle between A and B. Is that clear or not? So now here net electric field will be how much? It's very simple then. So net electric field is nothing. The magnitude of net electric field basically is nothing but root over. Since these two electric fields are same, so we'll write directly E square plus E square plus twice E square cos 60. and cos 60 is 1 by 2. So this and this got cancelled. So the answer is root 3e. So E net at any vertices, magnitude of E net at any vertices will be how much? Root 3e. And root 3e is equal to how much? 1 by 4 pi epsilon naught q by L square. Is that clear or not? मजा आया? Is this clear? ठीक है ना, तो बस सिंपल सी बात है, बस ऐसे ही करते जाओ, आंसर मिलते जाएगा। जब भी वेक्टर मिले तो उसको ड्रॉ करो, पहले क्या करो? ड्रॉ करो। चलो तो एक और एग्जांपल बनाते हैं, ट्राई करते हैं। जैसे मान लो ये तुम्हारे पास एक ऑक्टागन है, ओके, ऑक्टागन, and on each vertices I am placing a positive charge. ओके, चलो तो इस पे मैं सीरीज ऑफ 3 क्वेश्चंस कराऊंगा, उसको ध्यान से देखना। फर्स्ट क्वेश्चन, फाइंड द इलेक्ट्रिक फील्ड एट सेंटर। व्हाई वी नीड सेंटर ऑफ मास फॉर दैट? हाँ, these are charged particles or not? Did I mention about mass? No na? हाँ, हाँ. So what is the electric field at the center? बताओ कितना होगा? अच्छा एक बात होगा, चलो करते हैं। प्लस क्यू की वजह से इलेक्ट्रिक फील्ड का डायरेक्शन किस डायरेक्शन में होगा? इधर। इस प्लस क्यू की वजह से किस डायरेक्शन में? इधर। तो एक बात होगा, अच्छा डिस्टेंस तो सेम है, तो जो इलेक्ट्रिक फील्ड होगी वो एग्जैक्टली सेम होगी या नहीं होगी? है ना? अच्छा सिमिलरली इस प्लस क्यू और उस प्लस क्यू को पकड़े, इस प्लस क्यू की वजह से सेंटर पे इस डायरेक्शन में, इस प्लस क्यू की वजह से इस डायरेक्शन में, है ना? इस प्लस क्यू की वजह से इस डायरेक्शन में, और इस प्लस क्यू की वजह से इस डायरेक्शन में, इस प्लस क्यू की वजह से इस डायरेक्शन में, और इस प्लस क्यू की वजह से इस डायरेक्शन में। तो ध्यान से देखो जरा, हर बार जो इलेक्ट्रिक फील्ड आ रहा है उसका एक इक्वल एंड अपोजिट पेयर बन रहा है नहीं बन रहा? तुम ही खुद से सोचो, अगर मान लो एक थ्रेड है और इधर से हम दोनों जब सेम फोर्स से खींचेंगे तो नेट फोर्स थ्रेड पे क्या हो जाएगा? जीरो। क्या हो जाएगा? तो नेट इलेक्ट्रिक फील्ड, फर्स्ट आंसर, नेट इलेक्ट्रिक फील्ड एट द सेंटर इज हाउ मच? जीरो, isn't it? सेकंड क्वेश्चन बताओ, फाइंड द इलेक्ट्रिक फील्ड at center when one of the charges is removed. Find the electric field at the center when one of the charges is removed. बताओ क्या होगा? तो ध्यान से देखा जाए, समझो जरा, if I remove one of the charges, what will happen? If this charge is removed, this whole thing will be removed from here or not? Yes, isn't it? and if that whole thing is removed, what you will see that due to this plus q, one electric field is is remaining unbalanced, and this is present in this direction, isn't it? Yes. Other electric field gets this and this got cancelled out, this and this got cancelled out, this and this got cancelled out. What is left? Only one electric field is left, isn't it? Let's suppose the distance from this charge till the center is a. Okay. So the electric field will be how much? Electric field is just due to one charge. So E net at the center is simple, 1 by 4 pi epsilon naught q by r square. If there will be two charges removed, two electric fields will be left. So it will be 2 times of 1 by 4 pi epsilon naught q by r square. So this is what you have to always understand, that as many charges are removed in this kind of symmetrical configuration, as many electric fields will start appearing. Is that clear or not? Okay. Try to do this third question of this time. Find the electric field at center when one of the charge is replaced by a negative charge, a similar negative charge. बताओ. Third question. Means what we did is that previously in second question I removed it. This time I'm not removing, I'm just replacing one of the charge as minus q over here. Right or not? All are plus q and one of the charges are considered to be minus q. Then find the amount of electric field at the center. Think. नैनो अच्छा देखो, ये तीनों चार्ज के वजह से और इसके अपोजिट तीनों चार्ज की वजह से नेट इलेक्ट्रिक फील्ड क्या हो जाएगा? कैंसिल, isn't it? But due to this plus q, the electric field will be in which direction? This direction. Due to minus q, the electric field will be also in this direction only or not? Yes. And from both of the charges, the distance is same, a, isn't it? Of the origin. Are you able to get me? So net electric field are due to two charges. One is E due to plus Q, and they are in same direction, so they will be added. E due to minus Q, and the angle is also in the same 0 degree, so no need to consider vector sign also. Are you able to get me or not? So the answer will become how much? 1 by 4 pi epsilon naught q by r square, and as I have already taken the direction of electric field, no need to consider the sign. Okay. Q by r square. So answer is 2q by 4 pi epsilon naught r square. That's my net electric field at center. Is that clear? Of course you can write, but we have the value of 1 by 4 pi epsilon naught directly as 9 10 to the power of 9. So that's why we do not interfere with that value. Okay. Is this clear? मजा आया? फील आया? ठीक है? चलो. Now, so we did many types of questions. Now let us move to once again important point which we call it as null point. Give the heading null point in the electric field. Just like in force case, we have equilibrium point now. Yes. And then we defined a stable, unstable equilibrium, all those cases, isn't it? So in electric field, we have null points. What we define it as? Okay. Now the question arises that what is this null point, or this null point is known by another name. It is also called as neutral point. It is not an equilibrium point right now. Good or not? Yeah, it is different from equilibrium right now. Okay, because equilibrium point, look over here, like here when we discussed equilibrium, then equilibrium has three types, isn't it? Stable, unstable, and neutral. So instead means we had different considerations for that. But here it is not an equilibrium point. We are calling it as null point. क्या बोल रहे हैं basically इसको? Null point, which is itself a neutral point. Are you able to get me or not? So देखो होता क्या actually में neutral point? Let us first define that like in the surrounding of many charges, we know that in the surrounding of two or more charges, if the net electric field becomes zero, if the net electric field at a finite point becomes zero, then that finite point is called as null point or neutral point. See, when force is zero, we call it as equilibrium point. Got it or not? When net force is zero at any point, we call it as equilibrium point. But that is not a neutral point. It can be neutral, stable, or unstable. Three different cases can appear over there. Are you able to get me or not? But we know that one thing is damn sure that if the electric field is zero, then it is definitely a neutral point or a null point. Are you able to get me or not? So let us do that in simple way. Let us select some charges. We have to only do on basis of two different charges, not many charges. So let's suppose I have two different charges. Okay, and I place them on a same line. No, it or not. One is plus q, second one is also plus q, and they are separated by some distance r. I call it as plus q1, and this one is called as plus q2. Are you able to get me or not? And they are separated by some distance r. This distance gap is given to you, which is exactly equal to how much r. Then I told you that find the null point. So we know that the null point will exist at some distance away from any of the charges, isn't it? So let's suppose this distance from q1 is how much? X. How much is that? X. Then from q2 it will be at how much distance? R minus x, isn't it? R minus x distance. Now, we know that if this is at x and this is at r minus x due to plus q1, the electric field will be in which direction? The electric field due to plus q1 will be in this direction, isn't it? I call it as E1. And due to q2, the electric field will be in which direction? Opposite direction. I call it as E2, isn't it? And if it is a null point and net electric field is 0, then that means what? E1 must be equal to at E2 to for that point P to be a neutral point or not, isn't it? So E1 is how much? 1 by 4 pi epsilon naught Q1 by x square, and E2 is how much? 1 by 4 pi epsilon naught Q2 by how much? R minus X का whole square, isn't it? So this becomes how much? This will be exactly equal to R minus X divided by X का whole square, 1 by 4 pi epsilon naught, this and this got cancelled, and that is exactly equal to Q2 by Q1. Is that clear or not? So this becomes how much? R by X minus 1. So can be written as 1 plus root under Q2 by Q1, and this gives us the value of R and X over here. Is that clear or not? So that means X is equal to R root under Q1 divided by root under Q1 plus root under Q2, and this is how my null point is calculated. And this is how, actually this is similar to the value of force equation, but these are two different understanding. In force, this X is a equilibrium point if you use the net force equation, but in using electric field, this X will be called as a null point. Are you able to get me or not? Is that clear? Confirm हो? ठीक है ना? चलो तो लेट सपोज let's suppose I give you a question. There are two charges. One is one is plus minus 16 microcoulombs or minus 16 coulombs. Okay, microcoulombs, right? Microcoulombs. And another one is plus 4 microcoulomb. The question is, find the null point if the gap between them, initial gap between them, is 10 centimeters. If the initial gap between them is 10 centimeters, find the null point. Yeah, one is negative, one is positive. चलेगा? बताओ जल्दी से, फाइंड द नल पॉइंट. अच्छा पहले ये बताओ नल पॉइंट कहाँ पर रहा है? आई एम स्पेसिफाइंग. लेट्स सपोज देयर आर थ्री रीजंस, रीजन 1, रीजन 2 and reason 3. Tell me where the null point will be find out. 1, 2 or 3. First thing, remember that a null point is always nearer to a smallest charge. Is always nearer to smallest charge. Yeah. Every time a null point is always nearer to which charge? Smallest. Then I means that means that null point will be definitely formed around plus 4 coulomb. But look over here. Let's suppose I said what? Yeah, of course. In terms of magnitude, what can be another preference to understand whether it is small or big? Huh? Acha, wow, wow. Very good, awesome. Clap. Okay, so let's suppose if this point can be null point or this point. So I selected 2 points, P1 or either P2. Which can be null point? Now you tell me. I know that the null point is nearest to the smallest charge, but then the question arises whether it will be P1 or P2. Then to understand that, listen, then to understand that we need to draw the electric field. For minus 16, the electric field will be in this direction. For plus 4, it will be in this direction. So look over here. Is this electric field can be zero ever? No, they are always in additive form. But at P2, we can see that due to minus 16, the electric field is in this direction, but due to plus 4, the electric field is in this direction. So which answer is correct? P2 is your correct answer. Is that clear or not? And P1, there is no null point. Is that clear? So look over here, the distance from, let's suppose, the distance from plus 4 for P2 is x distance. How much is that? X. Then for minus 16, it will be how much? 10 plus x. And I'm calculating in centimeters, x centimeter. So it will be 10 plus x centimeter and x centimeter, isn't it? So then you know that how to find x. X is what? X will be r. R is how much? 10 centimeter. Root under q1, root under q1. Okay, now here the question arises, which one you will consider as q1 and which one you will consider as q2. So ध्यान से देखो, where x is taken, from the charge from where x is taken, it will be considered as always q1. Are you able to get me or not? Okay, so x is taken from plus 4 coulomb, so x will be 10 centimeters plus 4 coulomb plus 4 microcoulomb divided by the root under, minus I'll not consider, so root under 16 plus root under 4. So this is 10 centimeter into 2 divided by 4 plus 2, which is 6. 2 3s are 6, and x is therefore how much centimeters? 10 by 3 centimeters away from plus 4 coulomb charge. Are you able to get me or not? Is that clear? Confirm. Hey, 1 minute. 1 minute, 1 minute. It is root under q1 plus q2. How much I'm getting from here? uh If it is 4 and 16, it will be r by x minus 1 is equal to q2 by q1. Okay, 1 minute. So I applied this trick and I got how much? 10 by 3. But actually you see, 1 minute, 1 minute. Actually you see that this trick is incorrect. Why it is incorrect? Because here it is 10 plus x centimeter. Are you able to get me or not? So look over here. This formula which we derived is only for similar charges. किसके लिए है बेटा ये? Wow, that's a nice thing. Nice thing I got today. That this formula is only for which kind of charges? So never ever calculate the null point for opposite charges with respect to that formula. Then what you will have to do, basically you will have to do nothing. Let's suppose this is the direction of electric field due to minus 16 and this is the direction of electric field due to 4. Then these two will be always equal. So e to the power e due to minus 16 microcoulombs must be equal to e due to 4 coulomb at that point P. Ah, yeah. So the answer will be 1 by 4 pi epsilon naught. Equation will e due to minus 16 at this point will be how much? 1 by 4 pi epsilon naught 16 microcoulombs divided by 10 plus x ka whole square is equal to 1 by 4 pi epsilon naught 4 microcoulombs by x का whole square. तो ये cancel 4 4 जा 16, and equation will be 10 plus x by x ka whole square is equal to 4. Are you able to get me or not? So this will a square root of 4. So this means I got 10 by x plus 1 is exactly equal to how much? 2. Are you able to get me or not? And 2 minus 1 is 1. So the x value, this means x is equal to how much? 10 centimeters away. So that means that this point P is also exactly how much centimeters away? 10 centimeter away from plus 4 microcoulomb charge. Are you able to get me or not? Is this clear? Is this totally clear or not? Okay. Okay. So we got to know so many things. We got to know about the charges and all. Now, the point is, let us just draw the graphical representation of these electric field, isn't it? Okay. So let us just means I want to represent that what will be the diagram for the electric field with respect to different charges. So we are plotting now electric field versus distance graph. ठीक है? Yeah, we'll come on that. So this is my diagram. Let me just have a yeah. Okay. So now look over here. Now I can draw many graphs. Okay. So let's suppose if I place first a positive charge. Okay. 1 minute. I'll draw in this sense. Control V. Yeah. Like this way. Okay. So now let's suppose if I have a positive charge at the center. 1 minute. Okay. This can't be drawn like this way. Okay. So let's suppose I place some positive charge plus Q. But what the hell is happening? This is why it is going back. 1 minute. Control V. Then previous. It's going back. I don't know. Okay, let me delete it. ध्यान से देखो, मान लो कि अपन ने एक पॉजिटिव चार्ज कंसीडर किया सेंटर पे. ओके, प्लस क्यू. अच्छा, अब इस प्लस क्यू की वजह से इलेक्ट्रिक फील्ड का डायरेक्शन क्या होगा तुम्हें मालूम है कि प्लस क्यू के लिए इलेक्ट्रिक फील्ड ऑलवेज पॉइंट आउट करेगा किस डायरेक्शन में? अवे फ्रॉम द चार्ज, इजंट इट? Y axis represents the electric field and x axis represents my distance. We know that electric field is always inversely proportional to distance square, isn't it? तो प्लस क्यू के लिए क्या होगा? सिंपल सी बात है कि सर इलेक्ट्रिक फील्ड ऑलवेज पॉइंट्स अवे फ्रॉम द चार्ज, एंड that means when I am nearer to the charge I'll feel the maximum electric field or not, and when I will go away from the charge I'll feel the minimum electric field. So diagram कैसा होगा? Yeah, hyperbola, not a parabola. It will be a rectangular hyperbola. Are you able to get me or not? Similarly, if I have a minus charge, now this is electric field. Electric field is positive. Okay, this is away from the charge. Okay, so this is why this diagram is there. Now, let's suppose if there is a minus charge. If at the center minus q is present, what is present? Minus capital Q. And this is electric field and this is distance. Then tell me, what will be the diagram? For positive charge, the diagram is like this way, isn't it? Means, so nearer to the distance, the electric field will be maximum. Away from the charge, the electric field will be minimum. Now for minus q, the electric field is actually in the opposite direction of the distance. Yeah. So why minus 1 by r? How come? That's not true. Magnitude wise, it is same. It is 1 by r square only. But the electric field for माइनस क्यू, जैसे जैसे हम दूर जाते हैं इलेक्ट्रिक फील्ड की डायरेक्शन एक्चुअली में अपोजिट होती है ना, आर वेक्टर इधर रहता है, इलेक्ट्रिक फील्ड पीछे की ओर रहता है, isn't it? So that means if I consider for that the electric field is negative when the r vector is positive, तो r vector positive कब होगा? Means electric r vector will start appearing in this direction, isn't it? And the electric field is negative for that. Are you able to get me or not? So when I am nearer to the charge, the electric field is maximum. When I am away from the charge, the electric field is minimum. So क्या आएगा? The graph will be like this way. Is that clear or not? This means I am nearer to the charge, the electric field is maximum, but in the opposite direction of the position vector. When I am away from the charge, when I am totally away from the charge, the electric field is minimum, but in which direction? Opposite direction. Is that clear or not? मेरी बात समझ में आई? Confirm. Hey, 1 minute. No, it's not like that. Shit, I forgot one thing. That if R is positive, then the electric field is negative. Okay, so the diagram will be like this way. Sorry. Oh. Because we know that, okay, draws अच्छे से. Yeah. So when R is negative, the electric field is positive. When R becomes positive, the electric field becomes what? Negative. So this is the direction diagram of electric field for the negative charge. Which kind of charge? And for positive, when R is positive, electric field is also positive. When R will be negative, electric field will be also what? कैसा रहेगा? नेगेटिव. मतलब अगर तुमने R को मेजर किया किस डायरेक्शन में बेटा? नेगेटिव डायरेक्शन में, तो इलेक्ट्रिक फील्ड भी उसी डायरेक्शन में बढ़ेगा, है कि नहीं? Is that clear? So this is the diagram for electric field with respect to distance for positive charge and negative charge. Are you able to get me? Confirm हो? और इसका रेप्लिका बनाना है यार. ठीक है, इसको बना लेना अच्छे से, कॉपी में अच्छे से ड्रॉ हो जाएगा. मेरे से थोड़ा सा दिक्कत हो रहा है. ओके, चलो. तो दिस वाज पॉजिटिव एंड दिस वाज नेगेटिव. नाउ अब एक बात बताओ, अगर हम ध्यान से सोचें तो अपने पास पेयर ऑफ पॉजिटिव चार्ज भी तो हो सकता है ना. अब मेन चीज स्टार्ट हो रहा है. सो लेट्स सपोज इफ आई हैव पेयर ऑफ पॉजिटिव चार्जेस. ठीक है, let's suppose if I have pair of which charges. So let's suppose here one positive charge is placed and here one positive charge is placed. ठीक है, अब बताओ डायग्राम कैसा होगा? What will be the diagram of electric field with respect to distance? तो पहली बात, अगर हम चार्ज से दूर जाएंगे तो डायग्राम कैसा हो जाएगा सर? सिंपल सी बात हमें मालूम है. दिस विल बी द डायग्राम फॉर दिस पॉजिटिव चार्ज, isn't it? अब एक बात बताओ, दो पॉजिटिव चार्ज हैं तो उनके बीच में एक नल पॉइंट आएगा या नहीं आएगा? आएगा ना. तो इस नल पॉइंट पर क्या होगा? ध्यान से देखो, तो जो चार्ज की वेरिएशन है, यहां पर इलेक्ट्रिक फील्ड की वैल्यू क्या हो जा रही है? 0. तो नल पॉइंट पे इलेक्ट्रिक फील्ड क्या कर जाएगा? इसके साथ ऐसे टच हो जाएगा फॉर दिस प्लस क्यू, isn't it? सिमिलरली हमें मालूम है इलेक्ट्रिक फील्ड नियरर टू चार्ज बहुत ज्यादा होगा और नल पॉइंट पे क्या हो जाएगा? 0 1 सेकेंड. कैसा आएगा, इस तरह से, और ये प्लस क्यू का तुम्हें इधर तो कुछ नल पॉइंट नहीं रहेगा, तो डायग्राम विल बी लाइक दिस. So this will be your actual diagram for the two pair of positive charges. Why? Because there is a creation of a null point in between the charge. Is that clear or not? मेरी बात समझ में आई? Is that clear? Similarly, let's suppose if I take two negative charge, let's suppose if I have a pair of two negative charges, one is minus q, another one is also minus q. Then कैसा होगा इलेक्ट्रिक फील्ड वर्सेस डिस्टेंस डायग्राम? नेगेटिव चार्ज का कैसे होता है बताओ? अभी हमने ड्रॉ अभी हमने ड्रॉ किया था, नेगेटिव चार्ज का कैसा होता है? पॉजिटिव, नेगेटिव आर के लिए ई पॉजिटिव, पॉजिटिव आर के लिए ई कैसा रहेगा? नेगेटिव. तो सिंपल सी बात है, पॉजिटिव आर है तो ई की वैल्यू क्या हो जाएगी? नेगेटिव, है ना? इज दैट क्लियर? इसमें भी नेगेटिव आर के लिए आर ई की वैल्यू क्या हो जाएगी? पॉजिटिव. बट वन सेकेंड, दो सिमिलर नेगेटिव चार्ज है तो एक नल पॉइंट आएगा ना? क्या आएगा एक बीच में? नल पॉइंट, है ना? डायग्राम कैसा होगा? 1 मिनट. तो ई पहले नजदीक में चार्ज पे मैक्सिमम होगा, नल पॉइंट पे क्या हो गया? जीरो. सिमिलरली इधर से हम जब जाएंगे तो नल पॉइंट पे इलेक्ट्रिक फील्ड क्या हो जाएगा? जीरो. आर एबल टू गेट मी और नॉट? इज दैट क्लियर? एंड दिस वन विल vary as it is. So the diagram will be like this way for the two pair of negative charges. Is that clear or not? Confirm? Now last pair of positive and negative. Yeah, plus q and minus q, isn't it? अच्छा, ये किसने बोला कि नल पॉइंट बाहर होगा? We did. Yes, we did. Definitely we did. अच्छा, if it is similar, then what will happen? Is it away? Let's suppose, I'll tell you. One is plus q, another one is minus q. Okay. And this is electric field. And this is my distance. Then draw the डायरेक्शन. अच्छा, जब कौन कौन से चार्ज है? सेम पॉजिटिव एंड नेगेटिव है, प्लस क्यू और माइनस क्यू. तो इलेक्ट्रिक फील्ड ऑफ कोर्स किस रीजन में होना चाहिए? बीच में होना चाहिए या फिर बाहर होना चाहिए? हाँ हाँ, सोचना जरा. बीच में नहीं होगा. देखो, अगर मान लो, कैलकुलेशन कर लेते हैं, अगर मान लो एक पॉजिटिव है प्लस क्यू और एक माइनस क्यू, जिनके बीच की डिस्टेंस कितनी दी गई है? डी. जिनकी बीच की डिस्टेंस कितनी दी गई है? डी, isn't it? The question arises that where is the null point? Where is the null point? Isn't it? बहुत अच्छा क्वेश्चन है ये, बहुत ही अच्छा क्वेश्चन है. There are two similar charges, then find the null point. So how to find? We know that for null point, the electric field will be equal to how much? Zero. Isn't it? अच्छा, एक मैं कंक्लूजन ले रहा हूँ. आई एम जस्ट टेकिंग वन कंक्लूजन. ओके, आई एम कंसिडरिंग दैट at some distance x from one of the charge, some distance x from one of the charge, there is a null point in between the charge itself. Okay, is that clear or not? ठीक. Then what we can see that for this charge, for plus q, the electric field is in which direction? This direction. An electric field for minus q is also in which direction? This direction. So is it going to be a null point? No, that is not my null point. Then where is my null point basically? Somewhere out. That's true. That this null point is not present over here. It must be. तो बताओ कहाँ पर होगा? Somewhere out means where? That's the biggest question or not? Because these are two similar charges. So let's suppose from minus q, I consider, let's suppose this null point is at this point. Okay, minus q के पास. ठीक. So from minus q it is at what distance? X distance. From plus q it is at what distance? D plus x. For plus q, the electric field will be in which direction? This direction. For minus q, the electric field will be in which direction? This direction, isn't it? So when I do the calculation, what I will get? This is E due to minus q. This is E due to plus q. So these two must be equal. E due to plus q must be equal to E due to minus q. So equation will be what? 1 by 4 pi epsilon naught plus q divided by, या ऐसे लिख दो, q बाई डी प्लस एक्स का होल स्क्वायर. एंड ई ड्यू टू माइनस क्यू क्या होगा? 1 बाई 4 पाई एप्सिलॉन नॉट q बाई एक्स स्क्वायर, इजंट इट? ये पूरा का पूरा टर्म क्या हो गया? कैंसिल. बचेगा क्या? x, या फिर ऐसे लिख लो, d प्लस एक्स बाई एक्स का होल स्क्वायर इज एग्जैक्टली इक्वल टू हाउ मच? 1, इजंट इट? तो इक्वेशन क्या आएगा? d बाई एक्स प्लस 1 इज इक्वल टू प्लस माइनस 1 लिखना होगा. यहाँ पे क्या लिखना होगा? Because these are two similar charges. Because these are which kind of charges? Similar charges. So then I will get d by x is equal to, if it is plus 1, then it will be 0. What will be the answer? It will be minus 1 minus 1. So d by x is equal to minus 2. For plus 1, the value will be what? 0, isn't it? So d by x, the first term is this. That means x is equal to minus d by 2, and the second point is x is equal to how much? If I just keep, red one, I'm doing red one, d by x plus 1 is equal to plus 1, then I get d by x is equal to how much? 0, and x is equal to infinity. So there are two terms, x is equal to minus d by 2 and x is equal to infinity. What are the terms? X is equal to minus d by 2 and x is equal to how much? What is minus d by 2 basically? It's not an outside point. It's an which point? Mean point. And this is what I wanted to show. And that is why I told you why there is a calculation of null point. That although the electric fields are in same direction, but this is a null point. Although the charges are of similar nature. Of course, it is contradictory. Uh, that's a nice question. I'll try to describe it tomorrow. Good or not? Okay. Yeah. Why it is over there? There is a very good description about that, and that we get from electric field lines. Okay, which I'll discuss tomorrow. Is that clear or not? Okay. So that is why in between plus q and minus q there is also a point which is my midpoint, and that is itself a null point. So now, okay. So the diagram will be for minus q. Distance is negative. Distance is positive. Electric field is negative. And for this, electric field becomes zero over here. And for this plus q, distance is positive. Electric field is also positive. And the diagram will be like this. Right or not? So the diagram is drawn like this way. Okay. The electric field is minimum in between the charge itself. When I calculate x, I get minus d by 2. And I'll discuss it tomorrow. Why at x is equal to minus d by 2. Yeah. ठीक है? So, do not call this as null point because electric field is not null. We'll call it as minimum. Yeah, yeah, there is very big significance. I'll discuss it tomorrow. We call it as minimum electric field. Okay, write it as minimum electric field because null point is where the electric field is totally zero. Okay, but here this is not a point of null point because electric fields are in same direction. But this is a point where I have minimum electric field. This is one of the nice conclusions we got. Okay, because we are aware that for plus q and minus q over here, do not write it as null point. Also write it as minimum electric field. Okay, we'll discuss why it is, why this. Uh, will come on that. Okay, so this was your discussion till now, and today we'll stop over here, and then we'll discuss tomorrow why this minimum electric field is called and why suddenly my null point or minimum electric field point, although by using E is equal to 0, by equating these equations for the two different similar opposite charges, I'm getting a midpoint to have a minimum electric field. And there is a reason for that. We'll come and understand tomorrow. Okay.